And today I will introduce the behavioral response of wild Pacific salmon and herring to boat noise. So let's see this picture. What did you see in this page? You maybe only see a cool ball on the sea, but I saw a school of fish getting noise pollution. You know, when we think about marine pollution, I think we usually think about plastics, maybe toxic chemicals, or even ocean acidification from climate change. But when I was reading this paper, I realized noise is another important kind of pollution, one that often gets ignored. This is important. It can affect marine life ability to find food and mate and to listen out for predators and more. And here is the sound of sonar by record underwater. Let's listen. And this is the sound of ship passing. So you can imagine how painful it is for these schools of fish to live with this sound every day. According to other paper, they found Atlantic herring and Atlantic cod have been found to make horizon and vertical movement. For what? For this noise. They get away from this noise, so they change their behavior. In addition, ball noise also affects fish behavior by increasing predation risk, reducing the fish size of their home range, or changing day-night activity patterns. Then, a growing body of research is showing that noise from shipping and other human activity can reduce the communication space of fish, and it could affect survival, reproduction, and the population growth of fish. Now let's briefly introduce this experiment. First, all savages are juvenile salmon and chong and the Pacific herring. And these are their photos. Then what behavior are we going to observe in these fish? We will observe this behavior is squall cohesion and swimming speed and orientation. Finally, we need the noise source. We have to select the most common board. Uh, Here is what they look like, and their format is there. Okay. This photo is Pacific summer. Now let's start introduce material and the method. First, the location of this experiment is the Hutton Island. Hutton Island in the west of Canada. And this photo is observation platform. The captured fish will retain inside the observation platform for no longer than 8 days, after which they will release back into the wild. Salmon and the herring school will separate and given them 24 hours to adapt to the observation platform before experiment will start. How do they catch fish? Live fish collection was carried out by experienced local fishermen, and all fish in the study were caught within 30 kilometers of the experimental site. This, this means it can to limit transportation time and the distance, and to minimize stress to the fish. Then fish were housed in square containers filled with water from the catch site, which was oxygenated during transport. And the water temperature were in the container were the same as local water temperature. This page is an introduction to the experimental equipment and the methods. First, we use GRAS to make ship noise. Then, the hydrophone was installed inside the net at 1 meter depth to measure the receipt level from the experimental boat inside the net pen and to record any fish vocalization. The hydrophone was connected to a recorder and an amplifier, which allowed real-time monitoring of sound. And the fish score behavior was recorded continuously. And the continuously means before, during, and after boat change. And then they using 3 underwater cameras mounted on a pole at 23 centimeter depth in the corner of each net pen. Next, visual noise experiment use one of the 3 visual of varying length and entry. First, we monitor fish behavior 15 minutes in the situation of no ship passing. Then, operating the treatment visual path, the fish randomly varies speed and distance, and monitoring fish behavior during 3 minutes. After 3 minutes, the engine was shut down and the fish were allowed to recover for at least 1 hour before another trial was initiated. Okay, and scientists divide their behavior data into 3 categories. 3 categories. They assign their behavior to the corresponding value, and the 0 means no, 1 means is yes, and this is their behavior. Like loose squall, slow swimming, fast swimming. Okay, let's see what the result is. And the picture on the left is the hurry. Before discussing the results, we have 2 premises that we should know. First, now the natural ocean itself is not exactly quiet. If you put your head under the water, you can hear the quaking ice, wind, rain, and singing walls, even bubble sound. All together can create a soundscape of maybe 50 to 100 decibels, depending on where and when you are. On average, ambient was 105.2 decibel, and the small, medium, and the large strips includes the ambient noise of the experimental site by 12.4 decibel, 80 decibel, and 41.4 decibel respectively. Second, during flight trials, fish remain out of camera sight, and these were removed from analysis. Next, they calculate their data from mathematical formula, and we got a chart on the left. The chart shows that 50% of the herring and the salmon respond when sound level reach above 123 decibel or 140 decibel respectively. Finally, I will introduce the discussion of this paper. First, this paper have research funding. New research funding. During the ball noise, two schools of fish respond to the predator, but this was not a real predator. But if this reaction happens repeatedly, it can reduce their energy intake and health. Second, this paper also gives the research direction in the future. We can research marine mammals and fish who has evolved more successfully under the nose. If whales are better equipped to detect fish in a noise environment, then fish are a detecting predator. It means fish anti-predatory behavior may prove a maladjustment. That is to say, while with higher forensic success or ability to catch large schools of fish. In the end, what this research needs to be taken seriously. Now you have to remember we have evolved to be a visual species. We really rely on our eyes, but marine life relies on sound the way that we rely on sight. For them, a noise ocean may be confused and even dangerous as a dense fog is for us. Maybe some species can adapt this noise environment, but some species may become extinct. This study shows that animals are directly stressed by noise as well, so they often make bad decision in the one place. So the noise problem of the ocean is bigger than you think, and the noise pollution of the ocean is as serious as other marine pollution. Okay, thanks for listening.
I think I can give some some comment for his PowerPoint. I think can he do sorry I don't remember this word how to say. In Chinese say 对齐 the word.
Align.
Align the word because I see in his presentation the PowerPoint have a last word is not aligned.
He said my PowerPoint my slide was not aligned like this.
Hazel, did you mean like this?
Yes, like this.
And I will improve this.
I think you present some slides only for a few seconds and you just skip to the next slide. And I haven't get any message of your text and you skip just like at the fourth pages or 5 pages. Yeah. And I just focus on the fishes and I didn't read the message of your text and you skip. Yeah, I think it's maybe you can stay these pages longer that viewer can understand what this slide is talking about. Yeah.
He said when I present my slide with a short time and in a few seconds, I report this not because for the time, so I didn't say more detail for this paper.
I need to appreciate that you put so many pictures and even the voice recording in these slides. I think is very good, but there's still some little points can be improved. Like page 8. Can you switch to the page 8?
Yes.
Yes, you use the numbers and use the double digits numbers to display the experimental equipment. I think you can use simply just a bullet dot. because there's no related to steps or something. So if you use the bullet dots, you will be clear to demonstrate that. And as mentioned before, you haven't explained more detail about the slides, like page 9 and page 11. Page 9, yes, the behavior part. You just I can't understand purely about the behavior part because you spend I think 10 seconds and you can just skip to the next slide. So I hope you can explain this more. And page 11 about the axis part. Yeah, you haven't explained the x-axis and y-axis. And so I just can't understand what it's talking about this plot. That's it.
Oh, she said I didn't explain what is dose response and it's a y-axis and the x-axis. And she also said I didn't say more detail for this chart. That's all.
John.
I think this topic is interesting, but I want to know a word. What is score cohesion means in your page 9?
Okay, and score cohesion means is those scores mean the fish swimming in all directions and the different swimming speed. And the polarized score is mean they have the same direction and the same swimming speed in the observed in this experiment.
All right. So I think Aiden he talked very smoothly, calmly. So I think most of you can follow him. But apparently his slides can be further improved. The first thing, can you go to slide number 3 and 4? 3. Slide number 3.
Okay.
Yes. So you can see that here it is still introduction slides. But if you go to number 4, next slide, then it's already it's like a experiment introduction. So and the next one is also experimental material and method. So I don't know what is the purpose of this study. So as I mentioned many times, you need one specific slide explaining the purpose of this study. And then the next thing that he can definitely improve is if you go to slide number 9. Number 9. Yes, this one can be very much improved if you convert all these behaviors into cartoons. So you can easily draw cartoons yourself, like what is loose school, what is polarized school. You use cartoon to explain all this. Then slide number 7. 7. Yes, 7 and 8. These two are too technical, and these and you actually spend quite a lot of time here. So if I were you, I would minimize the time I spend on slide number 7, and for slide number 8, you have all these keywords, right? Like a GRAS, piston phone, etc. I will simply type these keywords directly on the slides, on the figure. So there's no this number 1, 2, 3, 4, 5. You just put everything on the photo, on the number, sorry, on the image. And then go to slide number 11. Right. You when you save time from these technical details, then you should spend more time on this figure. You can spend more time on explaining all this behavior. You can display cartoons, and then you have to spend time explaining the axis and what are the two curves. So they are actually the curve of two different kind of fish, and what are the dots here, and what does it mean by having this 0.5, etc. And what does the data mean? So this kind of introduction and interpretation was missing in your talk. And lastly, if you go to slide 13. 13. Right. I think this one is, first of all, I have never heard a purpose of discussion. So you can simply remove purpose of. Discussion is discussion. And then for the 1, 2, 3 points, I think these kinds of discussion, you see that new research finding, future research direction, why should it be taken seriously? This has no information. So, and then when you say new research finding, you were actually talking a lot, but because you were simply talking and you did not print any keywords here, or you did not show any corresponding images here, it was so easy for the audience to lose their attention. I was completely drifting away when you were talking the 3 points. So next time, please add more contents here. You can split the 3 points into 3 slides. And for each slide, print some keywords, add some photos, so we have a better understanding what is the message you want to say. And lastly, it would be really great that you add a concluding slides, add a conclusion slide. Okay, so